Howdy folks, Mr. Reed here, and welcome to One More Question. So what I'm going to be taking a look at right now is the graphing of a sinusoidal function. And I do it in kind of a peculiar way. I actually don't graph it on your normal XY coordinate axes. I kind of graph a floating function, and I'll show you what that means in just a moment. But this one I'm going to do for a sinusoidal function that is written in terms of degrees, and the next one I'm going to do it in terms of radians instead. So if you want to see me graph a sine or cosine function, you're in the right place. So let's get to it. Okay, so up above I have a negative cosine function actually. I'll write down what it is. So that is f of x is equal to negative 3 cosine of 6 onto x minus 70 degrees plus 7 at the end there. Okay, now if you've been following along and you've been doing transformations already, pretty much everything is identical, so that's going to be nice. One of the weird things is that we actually put in some different terminology. I didn't record a terminology video. I'm planning on it at some point, but I think I'm going to skip over it for now. So if you don't know the terminology, you should go take a look at it somewhere else. Come back, and I may be using those words a little bit interchangeably with the old things that are just going to be our vertical stretch, vertical translation, horizontal translation. All right, now I already have a couple axes built in, and I've done it in a way where I'm actually going to basically pay no attention to the function in order to make my picture, and then I'm going to change the labels to fit the transformations that have gone on here. So what I've got is a negative cosine function. So cosine functions generally start at 0 degrees up at the top at a positive one. Since this is a vertical reflection of that, we're actually going to be starting at the bottom. So I'll have a point at my quote-unquote beginning that will be at the bottom. And then I've labeled as I go over to the right quarters. So it goes from bottom to middle to top to middle to bottom. And all of the shapes of both sine and cosine functions are absolutely identical. So I'm going to try to the best of my ability to make a shape that kind of respects what's going on there. And it was okay. So this is one cycle or one full rotation of this particular cosine function. So I've already taken into account, I guess you could say, this negative sign that's on the very front. The next thing I'm going to take a look at is a combination of the other two parts that are vertical. So my vertical parts are this 3 on the front. That is a vertical stretch, or otherwise known as the amplitude when talking about sinusoidal functions. So we have an amplitude of 3, and we have a vertical displacement, or a location of the sinusoidal axis at y is equal to 7. Typically it's at 0, but we've moved this thing 7 units up vertically. That's what that 7 at the end means. So I'm actually going to say that this little line, my axes that I've drawn in earlier, I'm going to label that as being 7. So that's what I mean by kind of a floating axis sort of thing. So this picture is not representing the x and the y axes. This is not y is equal to 0 and x is equal to 0. So I'm going to use 7 there, and because my amplitude's 3, I go 3 up from 7 to give me 10, and 3 down from 7 to give me 4. So all my vertical stuff is done. That's actually really simple, really short, and sweet. All right, next up, I am going to switch things over to talking about the horizontal stuff. So that's always inside of the argument. In this case, I have a horizontal stretch factor of 1 over 6 because it's the reciprocal of the b value, which is 6. That means that my period normally, so maybe I'll put it as old period, would be 360 degrees if I'm talking about the one rotation or one cycle, one period, for something measured in degrees. My new period is going to be the old period, except for it's going to be stretched. So I guess I should put an equal sign there maybe. That's going to be 360 degrees stretched by a factor of 1 over 6. So in this case, I would have 1 over 6 as my stretch factor, and that's because it's the reciprocal of that b value. So 1/6 of 360 gives me a new period of 60 degrees. Now, that means it's going to take me 60 degrees to go from the very beginning of my one cycle to the very end of that one cycle. Now, something I usually do, which doesn't really matter, but I say my function kind of appears in quarters. So I go from the beginning to here, that's 1/4 of it. This is 2/4, 3/4, 4/4. So each of those cycles is very nicely split into 4 equal parts along the x-axis. So in this particular case, I have 60 for the entire cycle, which means I would have 4 dividing into 60, or just 15 degrees for each of those separate pieces. Now, I haven't labeled anything along my x-axis yet. I want to look at this part right here, which is a shift of 70 degrees to the right. Now, normally I would start my cosine function at 0, and in this case it's a negative cosine function, so it starts on the bottom. It would be at 0 degrees, but I've shifted this 70 degrees to the right, which means I think I'm going to label this axis right here as being 70 degrees. And then every 15 degrees, I get my next quarter. So I'm going to go 70 plus 15 is 85. 85 plus 15 is 100. 100 plus 15 is 115. And at the end, 115 plus 15 is going to give me 130 degrees. Now, if I just want to do a quick check, 70 plus 60 gives me my 130, so at least I didn't make any addition errors. At least I didn't make just a single addition error. I suppose I could make 2 by mistake and just really unfortunately luck into that final number. So this is all I would do to graph this particular function, actually. So I have pretty appropriate x-axis labeling. I've labeled all of my minimums, maximums, and the places where it cuts through the sinusoidal axis. Of course, we could always try to make it more accurate than this, but you're going to end up having a lot of points. So if you do something at the equivalent of the 30 degrees and 60 degrees mark, it's going to add on, I guess, a couple of new spots in each of these quarters. And you could even do the 45 degrees, and you could get really carried away. But I think that this is an appropriate amount of labeling, and as such, I'm pretty happy with this diagram. If you wanted to see it done on just a normal Cartesian plane, what would end up happening is this would be way up at 7, and it would be moved over 70 degrees, and it would be squished quite a bit because our period is only 60 compared to the original 360. So it would look a little bit like this. This is a poor approximation, but that's going to be like 3 or so cycles just kind of all written in. I like it better the way that I've done it, and in my classes I allow that to be the way that I accept graphs that my students do. So I hope that we found that one helpful. If you did, like, subscribe, and as always, take care, folks.